inside a note sheet, it gives you 3 different scenarios. One for linear systems. So in linear systems, you have 2 lines.
Bless you.
So linear system. Are you there right now? Yep. These 2 lines form a linear system. There is one solution for a linear system that's an intersecting line. So that means it's consistent because it has at least one solution, and it's independent because it only has one solution. Second graph that you see, lines coincide. This is the same line graphed twice. So if you have the same slope-intercept equation, so for this one it would be something like y equals 1 fx minus 2. You would have that, and you might have it in some different form, like 2y equals x minus 4. But when you actually graph it, it's the same line. The lines coincide, it's the same exact line, so it's consistent because it has at least one solution, and it's dependent because it has infinitely many solutions. So notice there's not something that says there are 2 solutions, because if there are 2 solutions to a line, it's the same line.
Right.
So it takes 2 points to form a line. Okay, the last one, lines are parallel. It's inconsistent, it has 0 solutions. These lines, they never intersect. There's never a point that is on this line and this line. They're parallel. Check whether A, 0.14, and B, -5, are solutions for the system. In order to be a solution for the system, it has to be true for both equations.
Wait, for both equations?
Both equations.
Wow.
If it's only true for one, it's a solution for the line. But if it's not a solution for both lines, like here, you could have a solution for this line here, but it's not a solution for the system because it's only on one line. It has to be on both lines. Okay, so let's check to see if point A is a solution first. In order for A to be a solution, it has to be true. This point has to be on both lines. Okay, so point A, we're going to take one, this is our x coordinate, and this is our y coordinate. And we're going to plug that into our x and y values for the first and second equation. So in the first equation, we say 1, which is our x value, minus 3 times 4, which is our y value. Is that equal to -5?
No.
No. 1 minus 12 does not equal -5. Okay, so this, we know A is not a solution. So already, we know this is not a solution. We don't need to plug it into the second equation because it's not going to be a solution for the system because it's not true for both of them. So for the second one, B, -5 and 0. -5 is our x value. 0 is our y value. Well, these are 2 separate points. So it's like part 1, question 1, is A a solution?
Wow.
Part 2, second question, is B a solution? So if it gives you multiple, like A, B, C, yes, you'll have to do every one. So for B, we'll say x, -5, minus 3 times 0. Does that equal -5? Yes, it does. So now we have to do the second one, because if it's a solution for the first line, and it's a solution for the second line, then it's a solution for the system. So -2 times -5 minus 3 times 0. Does that equal 10?
Yeah.
Wait, yes. Second way that we'll solve systems is by actually graphing. Sometimes you'll see your equations in standard form on your worksheet. You see them in standard form. You can always convert them to slope-intercept form, but you can also graph using standard form. So if you're given an equation in standard form, you should graph finding the x and the y intercepts. So go ahead and take some time to graph the first and second equation using x and y intercepts. And I will, while you guys work, I will do it on the screen. And then once you find your x and y intercepts, you can actually plot those points. And the second one. What's your solution for this linear system?
-1,
-1, 3. This is your solution. If you take this solution, this point, and you plug it back in, the x value of -1 and the y value of 3, if you plug it back into your original equation, it should be true both times. If it's not true both times, then recheck your math, but that's your double check, is plugging it back in to the original equation if you have one solution, if you have lines that intersect like this. Okay, so looking at this example 3 system with many or no solutions, again, you can graph using the x and y intercepts. So go ahead and graph using the x and y intercepts, and then tell whether the system has infinitely many solutions or no solutions. If you end up with y equals mx plus b, where your n and your b are the same, that's the same line. That means infinite solutions. If you end up with y equals mx plus b, where the slope is the same, where this is the same, but this b is different, then what do you have?
1, no solution.
Why? Why do you have no solutions?
Because the math says so.
You have parallel lines. So if your slope is the same, but your equation of the line is different, you have parallel lines, therefore no solutions. Okay, so when you graph these, you get the same x and y intercept for both equations, which means you have the same line twice. So you have infinitely many solutions.
Oh, I learned that.
Because every single point on this line is a solution, and a line consists of how many points?
2.
2. No.
You need 2 points to make a line.
Yeah.
Infinitely many.
But infinitely many
I
points
just
to make a
said
line.
that.
Sorry, I was on a different page.
So what is your x-intercept for the first equation?
2.
And your y-intercept?
3.
What about for your second equation, x-intercept? And y-intercept?
-1.
Okay, so if you plot these points, 2/3, -1, and 2, -3, what do you get? No solution, because your lines are parallel. Okay, now a good way to double check for no solutions is put it in slope-intercept form. Did anybody do that?
Is it the y?
Y equals mx plus b.
I did.
Okay, and what did you get for the first equation?
Y equals 3 halves x minus 3. And then for the second equation? 3 halves over, 3 halves x minus 1.
Okay, so here you have the same slope. Your slope is 3 halves for both of them, but your equation is not the same. So these two lines, they're parallel, but they're not the same because the equation is not exactly the same, but the slope is the same. So here you have no solutions.
Wait, is